Yeah, welcome back, dear students. So now today we are going to discuss module 3, which is the topic on introduction to embedded systems. Uh, Previous class, you people understood the register allocation, register allocation technique, conditional execution, and looping constructs. So with that we completed the previous module, that is module 2, and now we are going to discuss the module 3. The first chapter is introduction to embedded systems. You'll understand the basics with respect to the embedded systems here. Now, when I say embedded systems, now we are going to start with understanding the definition of the embedded systems itself. Now, before actually we understand the definition of the embedded system, Karana, we'll just try to understand what is a system. Now, you can define system in many ways. One definition for the system is it's a device that performs one or more tasks according to a set of rules. That is basically called as a system. A system is basically a device which performs, which has the capability to perform one or several tasks by following a set of procedures or the rules. That is what the system is. Now, there is one more way using which we can define the system. I think this definition is quite meaningful. Now, a system is a collection of interrelated components where all these interrelated components work together in order to achieve one or more tasks or one or more functions. So that is what is basically the system is, because many types. As a computer is also, you call it as a computer system. Why you call it as a computer system? Because again, when I say computer system, it's a collection of many interrelated components. When I say computer system, you should have the processor, you should have the memory, you should have the keyboard, all these things. And when all these components, that they're related, hence we call it as interrelated components. When all these interrelated components they work together, you have the operations of the computer system. You can do something using the computer system. If any one of the interrelated component is missing, then you cannot call it as a system. Now, similarly, you know operating system. It's called operating system. Why it's called operating system? Again, because it has many components, many interrelated components which work together in order to achieve some common task. Now, what are the components that you find inside, interrelated components that you find inside the operating system? There is process management component, there is memory management component, IO management component, like this. Now, when all these components, they interrelated component, they work together, they perform the tasks of what OS. Now, this is what is basically the definition of the systems. A system, you can define it in two ways. It's a device that basically performs one or several tasks by following a set of procedures. Another way of defining the system is that is a collection of interrelated components that work together to achieve one or more tasks. What are the examples you can give? You can give the computer system itself an example. Embedded system is one more example. That is what we are discussing, embedded system. But in general, we were discussing the definitions of embedded system, definition of the system, and operating system. This, and now embedded system. This is in general the definition of the system. Now we'll try to define what is an embedded system. Now, an embedded system is an electronic or electromechanical system designed to perform a specific function using a combination of both hardware and software. When I say software, it is a firmware. That means you cannot reprogram it. So the software which is permanently stored and it cannot be reprogrammed. Now, the embedded system is this. It's an electronic So purely an electronic, or sometimes it can also be an electromechanical system. Now why we say electromechanical? When I take robotics, so it is not, I cannot say it is only electronics. It involves the mechanical systems also, or the mechanical components also. Where so too many gears and things are involved. The electronic or electromechanical system designed to perform a specific function. It cannot perform the general functions, not all the functions. It can perform only the specific, the particular functions, using both the combination of hardware and software. When I say software here, it is the firmware. And I hope you understood the definition of embedded system. First you understood the definition of the system, collection of interrelated components, and later you understood the definition of a embedded system. An embedded system is either an electronic or electromechanical system which is designed to perform a specific task. In general, it can perform only a specific task or a specific function using a combination of both hardware and software. Now what are the examples of the embedded system? Now these are all the examples of the embedded system. I have shown few examples for the embedded systems in this slide. You have an industrial robot. So a simple robot which is used to pick the objects that are flowing on the conveyor belt. This is the picker. When the objects are flowing on the conveyor belt, this is the industrial robot which will pick those objects and perform. That is the only specific task it performs, picking the object that flowing the conveyor belt and giving it to one more robot which is specialized in packing those objects. And then similarly the GPS receiver is one more example for the embedded system. Digital cameras which you are using is also an embedded system. DVD players is an embedded system, and the wireless routers which you use in your homes is an embedded system. MP3 players which are used, set-up boxes, the TV set-up boxes, gaming consoles, the photocopier, these are action machine, microwave ovens. So plenty to list, and these are few of the examples which are shown here, embedded system examples. Now you understood the definition of the embedded systems, and later you understood few examples of the embedded systems. And every embedded system is unique in nature, and the hardware as well as the firmware which is used in the embedded system is specialized to an application domain. That means the hardware and the firmware software which is used inside the embedded system, it is not same across all the embedded devices. The software and the hardware which is used within the embedded system, it varies from one application domain to the another application domain. That means the hardware and the software or the firmware which we use in the embedded system is the application specific. Say for example, so I showed these many examples for the embedded system. In none of these embedded system, you don't have the same hardware and firmware that is being used. So and this behavior of embedded systems make them unique from one another. That means all embedded system, they are not same, they are unique. Embedded systems are becoming inevitable parts of any product or equipment in all the fields, including household appliances. That means you cannot make the list of the domains or the areas where the embedded systems are not used. So embedded systems these days are used in almost all the fields and almost all the domains. So here are a few domains or the areas where the embedded systems are being used, and I can say the embedded systems have become an inevitable parts in all these domains. Say for example, household appliances. Already in the previous slide I showed one example, that is microwave oven is there, and the refrigerators are also there. So in majority of the household appliances you'll find the embedded system, and in the telecommunication industry you'll find the embedded systems, because it may be in the form of the router, it may be in the form of the switches, like this, or in general you can say networking domain. And then the medical equipments, So majority meant into today's world. So you can list many of the medical equipments which are based on the embedded system. So plenty of them are there. For example, ECG machine, that is the best example for the embedded systems in the field of medical. And then industrial control systems, as I told, the robotics, this industrial robot which is specially used for picking the objects that are flowing the conveyor belt. And similarly, you can have packing robot also, the robot which picks the object from the conveyor belt and packs them accordingly. Now all these industrial embedded systems, they help in reducing the required manpower. And then the consumer products also. So they're to list, etc. I've written to list the domains or the fields where the embedded system is inevitable, is plenty, and you cannot list any of the domain or the area where the embedded system is not an inevitable part. All the domains and the areas embedded system is necessary. So now we understood the definition of the system, and later you understood the definition of an embedded system. Together, embedded system. Embedded system is an electronic or electromechanical system designed to perform a specific task using the combination of both the hardware and the firmware. So now we'll just see what is how IEEE is going to define the embedded system. Now IEEE defines the embedded systems like this. It defines the embedded system as a device which is lodged or placed in the other system and performs some specific task. Now this is how IEEE defines the embedded system. Embedded system is a device which is placed or housed or lodged in the other system in order to control its operation, and this performs the specific task. This is how the IEEE defines the embedded system. And here I have a simple schematic diagram of an embedded system in general. Now in the previous slide when I was explaining, I told embedded system is unique in nature, but this is what the simple schematic diagram which applies for all the embedded system. What makes them unique? The software components which you use and the hardware components which you use here make the embedded systems unique. But in general, any embedded system you take, they have the schematic diagram. They have the system inputs, and to embedded system, the inputs are majority of the time it is from the sensors, and the embedded system, as I said, it is a combination of both the software components and the hardware components, but the software component is a firmware, and then it has the system outputs. Now to embedded system, sensors are the inputs and the outputs are the actuators that we'll be discussing in a short while. So this is the simple schematic diagram of any embedded system in general. So, but the embedded system, they are unique based on the software component and the hardware component which are used inside. So now, what are the important characteristics of embedded systems in general? So there are a few important characteristics of embedded systems that distinguishes the embedded systems from the general computer systems. Now the first important characteristics is limited memory and limited peripheral. So the embedded system, they have limited memory and they have limited peripheral devices. That means they cannot operate with too many peripherals. They can operate with fewer peripherals at a time. And then when you're designing an embedded system, so this is what is important. This is one of the important design characteristics of an embedded system. That is, when you're designing an embedded system, you got to design in such a way that they operate at the lower power. And this, because most of the embedded systems are handheld devices and they will be operated by the battery backups. That is the reason we consider this as one of the design constraints or the design characteristics. And another thing is the embedded system should be designed to be highly reliable, stable, and safe. The embedded system should be highly reliable. That means the failure rate should be very low. Especially this characteristics of embedded system is highly required for the hard real-time systems, where there is no relaxation for the timing requirements. They must be highly reliable. The failure rates must be very low. They must be stable, and they must be safe. Now, say for example, we have many critical embedded systems like the heart pacemaker, the simple embedded system which is used in order to stimulate the human heartbeat. Now when I'm talking with respect to this embedded device, the heart pacemaker, so it must be highly reliable, and it must be stable, and it must be safe, because failure of such system will directly cause threat to the human life. This is one more important characteristics, and I mentioned the heart pacemaker, and similarly there are embedded systems which are used in the wheels of the flight gear system, and again they must be highly reliable, safe, secure, and there are embedded systems which are used in the satellites, and many critical embedded systems are like this, and embedded systems are even used in the ECG missions also, and the ECG mission must also be highly reliable. Okay. So these are few. This is one more important characteristics of the embedded system. Or in general, the embedded system must be highly reliable. If it reliable in the sense, you call some system as highly reliable only when it has very low or nil failure rates. And an embedded system must be designed to perform a specific function or a task. So embedded system, it cannot perform the variety of functions or the variety of tasks, or the tasks in general. So what it can perform is, it should be designed to perform a specific task, or a single task, or a set of tasks. And then the another important characteristics is with respect to the user interface. Now, what is an user interface? The interface through which the user will be interacting with the system. Here, when I mean system, it is an embedded system. Now, since most of the embedded systems are small in nature, and why they are small? Because they are designed to be handled. So most of the embedded systems are handled devices, and when I say handled, they have very small display panels. Now designing the user interface on those small display panels is again one more important characteristics, or the complicated design issue, what I can call the minimum user interface. Why minimum user interface? Because the display panel is small. Now within that display panel, what you can accommodate is only the minimum user. You can have minimum buttons, minimum text box. You cannot have larger number of text boxes and buttons. So through which the user will be basically interacting with the embedded systems. And the UI also looks little complicated, because you have too many UI elements like the buttons, the drop down boxes, all these things accommodated within the small display panel. So that is one more important characteristics. That means when you're designing an embedded system, you should give the utmost importance to design the user interface using on the small display panel, and you should also see that, so that UI which you're designing on the small UI panel is easy for the user to use, and should meet the real-time constraint. This is what I was mentioning. If the embedded system is a critical embedded system, now you got to design it in such a way that it performs its task within the real-time constraints without any delay or latency, and should be dependable. The embedded systems which you devise, especially again the critical embedded system, it should be dependable. What is the meaning of dependable? It should not cause threat to the human life, or threat to the environment in case of failure. If an embedded system wants to fail, so let it fail safely without causing threat to the human life, or the damage to the physical surrounding or environment. That is what is dependability is, because we use embedded systems, in the nuclear power plants, because human cannot monitor everything there. The restrictions for the human to easily walk around the nuclear power plants, and how do they monitor the functioning of the thermonuclear power plants? Now it is through the embedded systems. Now when embedded systems are doing all these things, it should be dependable. That means if the embedded system is failing for some reason, and if it is not able to function properly, it should see that there is nothing caused to the environment. It should fail safely. So that is what is important. And similarly, art pacemaker, I was saying, so that's an art pacemaker installed to the human body, and it regulates the human heartbeat. And if it is failing, it should fail safely without causing threat to the human life. That means how to fail safely without causing threat to the human life, by giving an alert to the user saying, I'm not going to function at this point of time, or this is what the reason for which I'm not able to provide the required service. So that is what is required. Should be. These are a few important characteristics of the embedded system. Now we are going to discuss the comparative study between the embedded system and the general computing system. Now when I say general computing system, it is your the general computer system. It may be a laptop or a desktop example. Okay. Now first we'll just try to understand the general computing systems with respect to the embedded system by looking into their contents. Now the system, general computing system, is a system which is a combination of general hardware, generic hardware, and general purpose operating system for executing variety of applications. So there is no restrictions here. Now when I say a general computing system which is having the generic hardware configuration and the general purpose operating system like the Windows operating system, Linux operating system, Mac operating system, Ubuntu operating system, so they can execute variety of application and no restrictions. Any application which you give to them, they're able to execute. Now what happens in the embedded systems here? So a system is a combination of special purpose hardware and embedded OS for executing a set of application. Now they don't have the generic hardware, so instead they have a special purpose hardware, the hardware which is specially designed in order to perform the execution of a specific application or a set of applications. And it is not again a general purpose operating system, it is an embedded OS which can execute only a set of applications. Now with respect to the OS, it contains a general purpose operating system as we already discussed. So now embedded system, it is not mandatory that always it should contain an embedded OS. So sometimes there will be an embedded OS, and sometimes there is no embedded OS. An embedded system in general may contain an embedded OS, or sometimes an embedded OS may not be there. Now alterations, applications are alterable. That means the application that is written by the user can be programmable. Any point of time the user can program. Say for example, I have the Windows 7 installed on my general computing system. Now I don't want Windows 7, I want to switch to the Windows 10. I can just uninstall Windows 7 and reinstall the Windows 10. Now the same is not possible in case of embedded system. In embedded system we say it is a firmware, so which is permanently stored, and it's not possible for anyone to reprogram them. That means they are not alterable, non-alterable, and here the applications are alterable, including the operating system. Here everything is firmware. Once it is done, it remains the same forever. And now key factor. Now when it comes to the general purpose computing, the performance is the key factor. Now when you're looking to buy a general purpose computing system, your focus is mainly on the performance, whether the system provides me the very good performance, then you buy that. Now embedded system, now the performance is not the only key deciding factor. There are other several factors also. Along with the performance, you should also check the power requirements. Now, say for example, you are interested in buying a cell phone. Now, you'll not only look into the performance of the cell phone, but at the same time, you also look into the power requirements. Now, if I once charge my cell phone, how long it gives the battery backup and memory usage, all these things. There are many things which you need to look in. Many key factors which you need to look in with respect to the embedded system, but when it comes to the general purpose computing system, performance is the only deciding key factor, because there we don't bother about the power requirements and the memory usage. Now, power consumption is obviously more here, because it's a general computing system which can execute many different varieties of applications, and it has a larger memory, all these things, and the power consumption here, it is less, and they are designed to consume less power, because majority of them are handheld devices and battery operated. Now, response time is not critical here, and when it comes to the question of embedded systems, it is critical for some application. We don't say it is critical for all the applications, and it is critical for some applications. Say an embedded system used in the satellites, embedded systems used in the thermonuclear power plants, embedded systems used in the cars also use ABS, that is anti-lock braking system. Now, these are all critical system. If something happens there, then there is a direct threat cost to the human life, and again heart pacemaker. So the response time is very much critical in all these things. Now, execution need not be deterministic. Now, here it must be deterministic for certain type of embedded system. ES means embedded system, like hard real-time system. That means when a task is getting executed in an embedded system, now it must complete its execution on time. But here some reasons, if it doesn't happen, with the predetermined time, so that there is nothing damage caused. But here there will be a lot of damage caused if the embedded system is not deterministic. Now, if it doesn't perform